Hi everyone, welcome again. First of all, I want to apologize for not being so active for last 3 months. I was in India with my family and didn't get time to upload videos or to work on the videos. Right. Going further, I will be uploading videos regularly. There are a lot of demand and ask from the people to make a series on Snowflake, to do more detailed lecture, more practical lectures. I will be working towards them, right? So let's start today's lecture. First of all, I want to wish you all a very happy new year, and hope in this year my videos will be valuable resources in your learning journey, right? So let's talk about Snowflake. So this lecture is continuation of the previous lecture of the Snowflake. The link of the video is on the right hand side corner, right? In the previous lecture of the Snowflake, what we talked about, what exactly Snowflake is, right? And how Snowflake works, what functions or what features Snowflake has, right? And how Snowflake is different from traditional data warehouses, right? And then when we talked about architecture, we touched upon three things: database storage, query processing, cloud services, right? And then we talked about additions. There are four types of additions: standard, enterprise, business critical, and VPS. VPS stands for virtual private Snowflake. Then we touched upon virtual warehouses. So virtual warehouses are simply referred to as warehouse, and this is nothing but a cluster of computer resources which Snowflake use behind the scene to compute or to process data for you, right? And then at the end of that previous lecture, we talked about micro partition and clustering. So micro partition and clustering are related to how Snowflake stores the data behind the scene. So this is what we have covered so far. So if we conclude what we have covered, we talked about theory, how data has been stored or how data is getting processed, what are different components, the terminologies which in like what Snowflake uses, right? This lecture is particularly about usage of Snowflake, how to run queries, how to create tables, what is time travel and fail safe, what are different types of table in Snowflake, what are different types of views, and then at the last we will be talking about UDFs or user defined functions, right? So let's start with lecture with Snowflake time travel and fail safe, right? So first talk about time travel. Before we jump into more technicality, let's talk in very simple language what time travel could be, right? So obviously time travel means travel back in time. It means travel back in time. And why do we want to travel back in time when we're talking about data? Just to retrieve the data which is deleted or the table has been dropped, or we want to back up at some point of time, of the data, right? So this is what time travel is, right? Now let's talk about fail safe. So fail safe means a safety feature or the disaster recovery feature, which should be our last resort. So for example, in even in general language, we talked about, okay, this option is my fail safe option. It means if nothing will work, I will reach out to this option, right? So this is what Snowflake, time travel and fail safe means in general. So let's jump into Snowflake terminology or technicality now. Um, so Snowflake provides a very powerful CDB feature for ensuring maintenance and availability of your historical data, the data that has been deleted or changed. So this line is very important. That historical data means the data which has been deleted or changed. So time travel is meant for the data which has been deleted or changed, right? So we can go up to 90 days back using a Snowflake time travel, right? So time travel can go back up to 90 days, right? And when we talk about fail safe, so fail safe, okay, so let's talk about time travel first. So time travel can be done by us, means users. It means if we by mistake deleted the data, we can get it back if time travel is enabled. Time travel is enabled, right? But when we talk about fail safe, it cannot be done by the users. It can only be done by Snowflake, right? Now, when we talk about both the features, these features are enabled in all types of editions. For example, it is enabled for standard edition, like what are the edition we have? Enterprise editions, business critical edition, and VPS. All types of editions, we have these features enabled. But for standard edition, the time travel is only for 1 day. If we want to extend the time travel, then we need to go for enterprise edition, right? And enterprise edition, we can go up to 90 days. One more important feature, or one more important thing, time travel and fail safes um, are not costing us any additional licensing fee. But since we are talking about historical data, we are talking about backing up, we are talking about disaster recovery, there will be storage cost for both these features. Okay. Um, so let's jump into time travel first, and then we'll talk about failsafe. So Snowflake time travels enables us accessing the historical data. And again, the historical data is the data which is changed or deleted at any point within the defined period. Right? It serves as a powerful tool for performing the following tasks: restoring the data-related objects. The data-related objects can be your tables, schemas, and databases. What it means that if we deleted a table, if we deleted a schema, or if we delete the whole database, we can still retrieve it back using your time travel feature, right? The next thing when we can use the time travel is to duplicating and backing up data from any key point in the past. For example, let's say we have a table with 100 rows, right? And the state of this table is, let's say, of 26th of November, right? And there is some flag called ABCD on 26th of November. And on 27th of November, we have updated this flag with any other value, let's say YZ or something. If we want to go back to 26th of November, when these flags are ABC, not XYZ, we can go up to that key point in the past, right? And then we can use this feature to analyze data usage manipulation over a specified time of period. We'll cover this feature in practicality, but let's think about how time travel works. So, first of all, in any SQL language, what we do standard operations. For example, queries, DDL, DML, right? So, whenever we do any standard operations, these are stored into your current data storage. Okay, once we delete the data, or once we drop the table, or once we drop the schema or database, that storage has been changed to time travel data retention, right? So the current operation or the current data will always be stored in your current data storage, and the time travel data will be stored into your time travel data retention, which is a separate storage, right? And um, when we want to retrieve data from this time travel, um, we will be using different operations or different keywords, which we'll be covering later, right? So, okay, so let's talk about um, how things works, right? So we have three types of operation: DDL operation, DML operation, and the new type of operations which Snowflake introduced is called time travel extension, right? So DDL operations is data definition language. For example, if we are creating the table or altering the database, right? Schema creation, schema alteration, or table creation or table alteration. This is your DDL, right? Then the next thing is your DML operations. For example, if we are inserting data, deleting data, so This is what your DML operations is. Now, Snowflake introduced some new feature in the time travel. For example, if we want to create the table from or at before some particular time, right? At or before some particular time. If we want to create the schema at or before some particular time event, right? And let's say if we drop the table, how we can undrop the table, schema, or database. So this is what time travel operations are. So time travel operations are mainly focused on at and before. This is further divided into three categories. I will be covering that in later. And then dropping and undropping. So basically, undrop is a Snowflake time travel extension operation. Okay, so let's further go. As I was talking to you, that Snowflake time travel will be supported by data retention, right? Obviously, if we want to retrieve data, if we want to retrieve our historical data, historical means changed or deleted data, that changed or deleted data needs to be stored somewhere. So Snowflake, ask us, okay, guys, can we store this data into some place, um, from the place where if you want the data after 2 days, 3 days, up to 90 days, we will get the data from that place and we'll give it to you, right? So this is your current storage. CS, you deleted some data and it goes to your, let's say, time travel storage. So what Snowflake say, that okay, if you delete the data, it will go to time travel storage, and it is up to you, um, till what time you want me to store the data, because obviously this storage will be costing you some extra money. Okay, so let me read it for you. Key component of Snowflake time travel is data retention period. When data in a table is modified, including deletion of the data, dropping an object, Snowflake, this line is important. Snowflake preserves the state of the data before the update. Snowflake preserves the state of the data before the data has been updated. The data retention period specifies the number of days for which the historical data is preserved. So the important word to note here is preserved, right? Time travel operations are, select, create, clone, and drop can be performed on the data. The standard retention period is 1 day and is automatically enabled for all Snowflake accounts. Snowflake standard edition, the retention period can be set to 0 or unset back to the default of the 1 day. For standard edition, we cannot increase more than 1 day, right? 1 day is the limit. For enterprise edition, we can increase it to 90 days. So there are different types of table. For example, we have transient table, we have permanent table, we have external table, we have temporary table. We will be talking about them later in 2 minutes. But uh, for different tables, for different editions, the Snowflake retention period is different. I won't be covering this right now. I'll cover it in 2 minutes. Okay, so retention period of 0 days for an object effectively disables the time travel. Obviously, so what it is written here, that if time travel or retention period is set to 0, what it means, that we cannot do the time travel. Historical data won't be available for querying. Past objects, can no longer be cloned. Past objects that were dropped can no longer be stored if the time travel retention period is set to 0. Okay, so this is time travel. So basically, time travel enables us to, for restoring the deleted data or the changed data. Okay, now let's talk about fail-safe. So as I was talking to you guys, fail-safe is the last resort. Fail-safe provides a non-configurable, so it means we cannot configure it, users cannot configure it, a 7-day period during which historical data may be recoverable by Snowflake. By whom? Snowflake. So time travel can be done by us users, and fail safe will be done by Snowflake. Time travel can go up from 0 to 90 days, and fail safe by default non-configurable, it's for 7 days, and it is enabled for all types of accounts and additions. This period now, when fail safe will start for you, this is important. This period starts immediately after time travel retention period ends. So let's say if your time travel or time travel retention period is 0 day. Time travel retention period is 0 day. It means whenever you insert data into this table and you deleted it, your 0 plus 7 days equal to 7 days will come effectively. So it means this data will be stored into fail safe memory or somewhere for 7 days, right? So this is important. Now note, however, that long-running queries, no long-running time travel query will delay moving any data and objects into fail-safe account until the query completes. Now, this is important. So let's say we are running, we are recovering data from where? From this memory. From this memory, time travel retention memory into the current storage again. So this query is taking, let's say, 15 minutes. So what Snowflake is saying, till the time this query is running, we cannot perform the fail-safe operation, right? So this is important as well. And now the next important thing, fail-safe is a data recovery service that is provided on a best effort basis and is intended only for the use when all the recovery options have been attempted. So these two lines says that this should be a last resort. We should not be relying on this service because obviously, you know, Snowflake says when all the options have been failed, you have attempted everything and you are not able to recover the data, then you should go to Snowflake, you know, if that fail safe is available. Fail safe is not provided as a means of assessing the historical data after the time travel retention period is ended. It is only by Snowflake, it should be only used by Snowflake to recover data. Now this line is very important, that has been lost or damaged due to extreme operational feature. For example, your server is crashed, your data center is on fire or something, anything. So which is extreme operation failures, right? Data recovery through failsafe may take several hours to several days to complete, right? So this is your time travel and failsafe. Now let's see the practical. So here I am. So what I've done so far, let me create a table, okay, first. So let me create one table. So my orders table is created. Order table has 4 columns: order ID, order date, order customer ID, and order status. Okay, now let me delete all the record first because I was working on it. So delete star from orders. Sorry. Delete, or we can say truncate orders. Okay, so it means there is no records into my orders table, right? So right now there is no records in my order tables. Now what I'm doing, I will be inserting some records into my order tables. So what it will do, it has inserted 12 records into it. Okay, so now if I go here and say select star from table order, so it will give me 12 records. Simple. Now what I'm doing, I will be deleting customer ID. Let me show you guys. Yeah, so customer ID, this one, 2233 from here. Let me delete it. Right, so one row is deleted. So when I'm selecting the order again, it will be 11 rows now, 11 rows, right? And the 223 is gone. 2233 is gone. Now, um, if I want to, see this data or check this data again, what I can do, I can use the time travel feature of here. So time travel can be done in three ways. One is through offset. Offset means go, up to this offset 16 to 12. It means up to this second back. Oh yeah. So either requested time is beyond allowed time travel period or before object time creation. Uh, or let's try this feature. 1841. This is working. So basically, if we see here, we have I went to the timestamp. um, I have deleted a row at 6:43 p.m. right, and I went to 6:41. So it means I went 2 minutes back when the data is there. Right now, let's say if I want to order customer ID is equal to 2233. Let's see if it is working. Yeah, it's working. So it means this record um, is present at 1841. Right now the time is 1843. Right. So now I have deleted that record. Let me write it down here. I have deleted that record at 1842. Which customer ID I have deleted? I have deleted 2233 customer ID. Now, if I go back 1 minute back from this query at 1641, right? So I should be able to see the data, which I'm able to see. See, the data is coming, right? Now, what I'll do, I'll say insert. How to take the backup, I'm showing it to you guys. Insert into orders, right? As select this. Let's try this. As should not be here. Okay, so one row is inserted. Now, when I go to the orders table directly, I can see 12 records are there and the customer number 2233 is already there. So this is how one option is working. Like for example, when we can travel back using timestamp. So how to do it? Let's see the query again. So basically, let's bring it here and let's comment this for 2 minutes. So how we are using time travel. So what we are saying, select star from orders, right? Our working table before timestamp. So basically, I remember that okay, I have deleted the data as 1642 or 1842. Now I want to bring data 1641 onwards. Okay, and then I need to say that this is timestamp. Okay, and this is optional if you want to see the deleted record. Else we can see all the records. It means it is storing data, or it is storing all the records into timetable retention storage. Okay, so this is how we're gonna be using timetable now. Why this query is not working? Because obviously, what I have done, I have created the table, right, and I've truncated the table. Then I have inserted records, and what I'm asking this that okay, go to this offset minus 60 into 12. It won't work. So let me do one thing, and again I'm trying one, and let's see. Okay, so now it's working. Why it was not working? Because there was no storage for this particular time. There was no timetable retention storage, right? So when we see here, it is coming for 12 rows now. So when we go here one, so this is other way of storing it or retrieving data. So when we go for offset is equal to 1, it is coming here, right? One more important thing, so these are two ways. One is using timestamp, other is using offset. Now the third way of getting back data is called using query. So let's see here. I should have written it somewhere. Yeah, this one. So basically, let me do one more thing. Let me delete one data. Let me delete one more data call for the customer ID 12111. So I'm deleting this one 12111, right? So I deleted it, right? And if I'll say select star from orders, like copy the same code, just show you guys data is not there. Select star from orders. So obviously the data won't be there, right? The query has produced no results. So basically, I have done one mistake actually. So let's me do one thing first. Uh, in fact, let me do one thing. I should have copied the query identifier or query number. So let me do one thing. So yeah. So let's do one thing here. Let's retrieve the record first. Sorry, let's retrieve the record first. From where I can retrieve it? I can retrieve it from here. Right, so we have offset is equal to, let's say, 10. So we have okay, so we have now that record here 2233, right? So what I'm doing now, I will be insert into orders, select this, and I'll copy this where clause. One second. Yeah, this one. Sorry, this where clause, right? So offset equal to this where this. So I'll do it now, and I'll tell you why I'm doing this. So insert where's two times. So what's working? Okay, so let me do it. 120, 130, 180. So let's say 6 minutes. Yeah. So basically, I'm going 183 minutes back, right? So I'm going for 3 minutes back. So basically, I can see here now, and let me put this customer ID here. Oh, sorry. Let me see quickly again. We have 11 records. Now I'll go for 190. We have, let's go for 240. Yeah, 12 records. So we have all the 12 records here. What I'm doing now, I will be inserting those 12 records into my table again. 12 record inserted, right? So if I go select here for this 50th line, I should be able to see the data. So I have two records now. So don't worry. So what I'm doing now, I will be deleting this. Okay, I will be deleting this, and this time, so query has been completed, right? So deleted two records. Now I'll do one thing: copy the query ID. So it means I will be copying the query ID, and I will be telling Snowflake that okay, give me everything which has present into your data retention storage before this particular statement. Right? So let me run it. So what it's showing, it is again showing me, so basically I've done some mistake, but it is showing me that record, which record we have deleted. So in fact, let's copy this just for your thing before this, and where this, let me show it to you. So we can see that record has been, the record is there into the data retention storage. Now we can recover it if you want. So this is how the query retention period works, right? In fact, let's use this here. Select star from orders. Oh, sorry, there's so many. Yeah. So the data has been retained. So there were two customer ID 12111 before the deletion, and now what we have seen, that before that delete statement, we have recovered two more, like the same number of records, right? Now let's see how drop and undrop will work. So let's say we have dropped the whole table, and when we select the orders table, it will say the table is not there, compilation error, right? The data has not been found. Now what we can do, we can undrop the table. See, the table has successfully restored, and now if we see the records, it will show us all the records. Okay, so this is how the time travel work. Now before we jump further, now I need to show you what is the storage, now how data has been restored into time travel or time travel retention storage and fail-safe storage. So basically, Snowflake um, stores all the storage information into account usage and the table called table storage. So this is the schema. Account usage the schema, and table storage matrix is the table name, right? So what I've done for my orders table, I'm asking Snowflake, okay, tell me storage used, timetable storage, fail-safe storage, right? Everything. So let's see. So it is taking some time. Okay. So what I'm seeing here, that with this storage, the data storage or the current storage is this one into GBs, and then time travel storage is 0.00006 in storage, and failsafe is not yet stored. Why? Now this is the question: why the failsafe storage is zero? It is zero because my time travel is still active. When time travel will end, this storage will be becoming maybe the same 0.0006. So this is all about time travel and fail-safe storage. Let's jump to the theory again. Yeah. So now let's talk about the fees. The fee are calculated each 24-hour period from the time of the data changed. So for example, if you change the data as of now at 6:55 p.m., the fee will be started after 12 hours, that is 21st of January, 6:55 p.m. The number of days, historical days data is maintained is based on the table type. Uh, I haven't covered the table type yet, but and time travel retention period for the table, right? So the retention or the number of days of the historical data maintained is based on two features or the two properties: table type and time travel retention period, right? Snowflake minimizes the amount of storage required for the historical data by maintaining only the information required to restore the individual table rows that were updated or deleted. So this is important. So let's say you have 12 rows, right? There were 12 order rows into my table, and I have deleted one row deleted. So what Snowflake is doing, Snowflake is not storing 12 rows into his time table retention storage. It is only storing the affected rows. This is important. As a result, storage is calculated as the percentage of the table that has been changed. Full copies of tables are only maintained when tables are dropped and truncated. Okay, so this is all about time travel. fail-safe. So in the next lecture, we will be talking about the table types, views, UDFs. Okay, thank you.